Hello everyone, greetings to you all. In this video, I would like us to learn how to perform permutations. A permutation is simply an ordered arrangement of items. Very important, an ordered arrangement of items is called a permutation. It's different from a combination. A combination is simply a selection. But here we are talking about an ordered arrangement of a number of items. For example, if you are asked the number of ways to arrange the books A, B, C, the number of permutations of the book A, B, C, A, B, C, A, B, C, the number of permutations will be the number of ways. So we have A, the book A first, followed by book B, book C. You can have A, C, B. You can have B, A, C. You can have B, C, A. You can have C, A, B, and C, C, B, A. C, B, A. So you have 1, 2, 3, 4, 5, 6. So you can do these permutations or these arrangements in 6 ways. Now, but to perform permutations, instead of obtaining it all like this, listing, what if you have 10 books to arrange? What if you have 10 permutations? And these permutations have varied applications, like in the case of even producing numbers, phone numbers from a SIM card. Those are permutations, the various arrangements. You see, somebody's number starting 67 is different from 76. So those are permutations that we are using, where the order is very, very important. Now, instead of rearranging all of this, what we can use is the factorial notation. The factorial notation goes thus. That n factorial is n times n minus 1 times n minus 2 times a continuous 3 times 2 times 1 times 1. And 0 factorial by definition is equal to 1. So the factorial notation will be very important. Now, if I wish to arrange ABC, the number of ways, I just use the multiplication principle, which will say A can be arranged, can be put in 1, 2, 3. So I have my 3 times B can be put in 2 ways, C 1. So 3 times 2 times 1 gives us 6 ways. Or using the concept of factorial notation is simply going to be 3 factorial, using the aspect of factorial notation. Now, looking again, we have combinations of all sorts, like when you have a permutation of n different objects taken r at a time. We write it as n permutation r, which is given thus: n factorial divided by n minus r factorial. N objects taking how many? R at a time. It means like those books. If you have 3 books to take all at a time, to take the 3 books, okay? So you to put all at a time, taking all at a time, following those arrangements, the permutations will be, it means you have 3 books, yes. You want to take the books all at once. How many are there? 3. So we are going to have 3 permutation 3, which will be 3 factorial over 3 minus 3 factorial. And 3 minus 3 is 0 factorial. 0 factorial is 1. So we have 3 factorial divided by 1. And 3 factorial means 3 times 2 times 1, which gives us 6 ways. So those are the various ways. We equally have, if we say how many different permutations can be made from the letters of the word chemistry. For example, chemistry. Okay, taking 4 at a time. What does that mean? It means our n 1, 2, 3, 4, 5, 6, 7, 8, 9. So our n is equal to 9. And if you are taking 4 at a time, it means r is equal to 4. R is equal to 4. So the total permutations will be 9 permutation 4, which will be 9 factorial divided by 9 minus 4, that's 5 factorial. Now for me to obtain this, 9 factorial is 9 times 8 times 7 times 6 times 5 factorial. And I divide by 5 factorial so that the 5 factorial will cancel. And we have our answer to that multiplication. Now we equally have permutations when some of the objects are alike. There's a number of permutations to obtain when some of the objects are alike. Like if you are the number of permutation of n objects taking r at a time, for which p of n objects, for which p are alike, q are alike, r are alike, and the rest different, is given by the number of permutations will give us the number n factorial divided by p factorial, q factorial, r factorial. Okay, for which that this p, q, r. For example, if we are asked to obtain the number of permutations, the total number of permutations for the word committee, a committee. Okay, we see that here we have 1c. Okay, yes, 1o. How many m's are there? 2. And we have 1i, then 2 t's, and e, 2. So what does that mean? It means the total number of arrangements will simply be how many n? 1, 2, 3, 4, 5, 6, 7, 8, 9. Will simply be 9 factorial divided by how many are alike? M is alike, so 2 of them are there, 2 factorial. 2 are here, 2 factorial. E, 2 factorial. Please, students, learners are warned, 2 factorial is not 2 factorial times 2 factorial times 2. It's not 8 factorial. You obtain your 2 factorial, which is 2. You obtain your 2 factorial, which is 2. So all of this, the denominator is 8. So 9 factorial divided by 8 will give us 4, 5, 360 ways. 360 ways. Then you equally have an arrangement that we call circular arrangement. If you want to obtain a circular arrangement that's round a circle, the number of permutations will simply be n minus 1 arrangement. N minus 1 factorial for the arrangement. That is, if you say how many ways can 9 balls be arranged in a circle, 9 balls for them to be arranged, it will simply be n is equal to 9. It will be 9 minus 1 factorial. Okay, 9 minus 1 factorial, which is 40,320 ways. That's for circular arrangement. Okay, that said, let's make sure we know the difference, how it is different from a combination. A combination is simply a selection. You are selecting from a certain set. Like you want to send a delegation of students from a school to represent the school in a competition. That is a selection. It is not an arrangement. It's not by choosing maybe Derek first or choosing any other person. Conditions for, like, you have this case without a condition. So a permutation, a combination, sorry, is simply is written as n combination R, which is defined as n factorial over n minus R factorial R factorial. Is that okay? So n objects are taken. N is the number, n objects, then R at the time from those objects. Those objects are taken. So it's a combination, it's simply an unordered selection of an or arrangement of a number of items. Unordered. Take note. Like they say, how many different committees of 3 persons can be made from 5? Of 3 persons can be made from 5. Let's say we have 5 students. We have Terence. We have Victory. We have Derek. We have Hilary. We have Jacob. There are 5, right? Now, if you want to make a committee of 3 persons from this, it will simply be that our n is 5. It will be 5. We're going to have 5 combination 3. 5 combination 3, it will give us the number of committees that can be formed. 5 here n factorial means 5 factorial. Now 5 minus r, that's 5 minus 3, which is 2 factorial, and r, which is 3 factorial. When we evaluate that, it gives us 10. So you form a committee of 10. Alright, thank you. Thank you for following up. Stay tuned to the next videos. Please like, subscribe, share. See you in the next video. Have a great time.